Our next topic in this chapter is empirical and molecular formula. Now, what is empirical formula? We can say it is the simplest formula. Now, what is the meaning of simplest formula? For example, we are taking C6H12O6 glucose. There are 6 carbon atoms in this, 12 hydrogen atoms and 6 oxygen atoms. The ratio of these atoms is 6 is to 12 is to 6. So this is not a simplest ratio. If I want to change to the simplest form, it will become 1, 2 and 1. 1 is to 2 is to 1. And from this the formula will become CH2O. So this formula when we are writing as the simplest whole number ratio of the constituent atoms, these constituent atoms of carbon, hydrogen, oxygen, their ratio we are writing in the simplest form, then that formula will become empirical formula. So this is empirical formula of glucose. And when exact number of the atoms in the carbon, we are taking hydrogen exact number 12, oxygen exact number 6 when we take, and we get this formula, this becomes molecular formula. So this is a difference in empirical formula and molecular formula. Molecular is exact one, while empirical is the simplest formula of a compound. Now, how to derive empirical formula? For that, we should first of all know about percentage composition of the elements in a compound. In this compound, how much is the percentage of each element like carbon, hydrogen and oxygen? So how to find out first of all the percentage composition? Calculation of percentage composition from formula of compound. To understand this, I am taking an example of magnesium sulfate. Our question is, calculate the percentage composition of various elements in it. That is percentage of magnesium, sulfur and oxygen we need to calculate in this from this formula. So first of all, we find out the molecular mass of this compound. Molecular mass of MgSO4 is equal to mass of magnesium 24 atomic mass, sulfur 32 and oxygen is 16 into 4, 64. This is magnesium, this is sulfur and this is oxygen. This total is 120. Now in this, how much is the percentage of magnesium? That will be equal to the mass of magnesium upon the total mass into 100. This will come out to be equal to 20%. Now similarly, we can find out the percentage of oxygen and sulfur in this. So next I am finding out the percentage of sulfur, which will be equal to mass of sulfur upon the mass of compound into 100, 26.67%. Similarly, percentage of oxygen is equal to mass of oxygen upon the mass of compound into 100, that is 53.33%. Like this, we can find out the percentage of all the elements in a compound from its formula. So once we know how to calculate the percentages of these elements, we can do next the empirical formula of compounds. So we are moving on to the empirical formula calculation. Now we know the definition of empirical formula. What is empirical formula? So directly I am moving on to the questions only. Now one sample problem I am taking for this. We have given the percentages of sodium, sulfur and oxygen. In a compound, sodium is 29.11, sulfur given is 40.51 and oxygen given is 30.38. These are the percentages of these elements given in a compound. And question is, find out its empirical formula, or we can say find out its simplest formula. Now how will find out its simplest formula? For that we need a table. To solve the empirical formula, we have to make one table. In this table, the first column is about the serial number. How many elements are there? Sodium, sulfur, oxygen. So 3 are there. And next after this we are writing the element symbols. Symbols of elements: sodium, sulfur, oxygen. Next, here is a percentage of these elements: 29.11, 40.51, and then we are writing 30.38. In next column, we will write the atomic mass, or we'll write the molecular mass, or we'll write the formula mass. That depends on the compound. So here we are using the elements only. So we are writing atomic masses for this question. Next after atomic mass is the moles of these elements. Moles of elements are equal to percentage divided by atomic mass. So percentage, first of all, atomic mass is 23, 32 and 16. Moles equal to percentage upon atomic mass. Percentage 29.11 upon atomic mass 23. Then is 40.51 upon 32. 30.36 upon 16. So this part we have to do very carefully. We can find out these values till the 2 or 3 decimal places we can find out. This comes out to be equal to 1.266, 1.266, and this is 1.897. Our next column now is, I'm moving this column, moving on to this one, simplest ratio. To find out the simplest ratio, because empirical formula is the simplest formula, so we need a simplest ratio. For that, from these values, we'll take the smallest value. This is the smallest value. All the values we have to divide by that smallest value. So this becomes 1.266 divided by 1.266. This is also 1.266 upon 1.266. Then is 1.897 upon 1.266. After dividing, this will become 1, this will become 1, and this is in a fraction 1.5. So if these values we are getting in whole number, then is okay. Otherwise, we need to change them to a whole number. So we have to add one more column here, simplest whole number ratio, simplest whole number ratio. And that we will get by multiplying these values, the fractional value, with some number, so that it can change to the whole number. So if I multiply 1.5 by 2, it will change to whole number, that is 3. But if we are multiplying this with some number to change to whole number, other values also we have to multiply with the same number. So actually we have 2 sodium, sulfur 2 here, and oxygen is 3. From here we can write empirical formula. To write empirical formula, we write the symbols of elements in a compound: sodium, sulfur, oxygen, with a little space in between. And here as subscript we write these numbers. Sodium is 2, sulfur is 2, oxygen is 3. This becomes empirical formula of this compound Na2S2O3. So now one thing more, when we are solving empirical formula, suppose in this question only sodium and sulfur percentage is given. Oxygen percentage is not given. So if oxygen percentage is not there, before reaching to the next column to atomic mass, what you will do is just take the sum of these. You see, if you take the sum of these, this comes out to be approximately 69-70%. Sum of percentages should always be equal to 100. If percentage does not come out to be equal to 100, approximately 97, 98, even if you are getting, it's okay. Then that means there is one more element, and that element will always be oxygen. And how we write the percentage of oxygen? Oxygen percentage will be 100 minus sum of percentages of these elements. So when you will subtract from 100 their percentage, you will get the percentage of oxygen. In case the percentage sum of elements given in the question does not come out to be equal to 100, then we have to write from our side only one more element, and that element will always be oxygen. So like this we can find our empirical formula of compounds. It's a very simple thing. Just learn the table only, the columns you should know, and calculations you have to do very carefully when you're doing these kind of numericals. After empirical formula, now we are doing molecular formula. To get molecular formula, first part is you have to find out empirical formula. So that step will remain the same only, that is calculation of empirical formula. Till this the steps will be same only. So I'm taking one question now to solve this. Let's take one question. Compound has hydrogen 4.07%, carbon 24.27%, and chlorine is 71.65%. These are given. Now along with this, molar mass of compound is also given, 98.96 gram. For the molecular formula numericals, molar mass of compound should be given to us in the numerical statement, or vapor density should be given to us. Now use of vapor density I'll tell you afterwards. In this numerical we are taking molar mass, and find out empirical formula and molecular formula of compound. These two we have to calculate. So our first column is element. Which elements are here? Hydrogen, carbon and chlorine are there. After elements we write their percentage. Hydrogen is 4.07, carbon 24.27 and chlorine is 71.65. After percentages, our next column is the atomic mass of these elements. Atomic mass of hydrogen 1, carbon is 12 and the Cl is 35.5. After this we write moles of these elements. Moles of elements are equal to percentage upon atomic mass. So after solving this, this will be 4.07. This one will be 2.02. This also will come out to be 2.02. Now next, after finding out moles, is the simplest molar ratio. Simplest molar ratio. And that we calculate by dividing these values with the lowest value. That is 4.07 upon 2.02 is 2. This is 2.02 upon 2.021. These are changing to whole number here only. So no need to add the next column here, simplest whole number ratio. Now from this we can write empirical formula of this compound. For this we write the elements first of all. Write them in any order here. So hydrogen is 2, carbon is 1 and Cl is 1. Actually it is your CH2Cl, but in these questions you write them in any order is okay. Now how to find out the molecular formula? Empirical formula we know. Now how to find out molecular formula? See the next step. Find out empirical formula mass. Like we find out molecular mass from the molecular formula. From empirical formula, if we calculate the mass, that becomes the empirical formula mass. Same way only. Atomic mass of hydrogen plus that of carbon plus that of Cl. This comes out to be equal to 49.5. After finding out this empirical formula mass, our next step is find out n value. N is a number. This is equal to molecular mass upon empirical formula mass. Molecular mass is given in the question 98.96 upon empirical formula mass 49.5. Even if you don't get a whole number value here, you get 1.9, you can write approximately 2, or 2.01, you can write approximately 2. This should be a whole number value. Now next step is very important. See, I said n is a number, but which number is this? A number which when multiplied with empirical formula changes empirical formula to molecular formula. So n is 2, empirical formula we have derived is CH2Cl, or you can write H2CCl anyway. So multiply this number with this empirical formula. Carbon becomes 2, hydrogen 4, and Cl becomes 2. So this becomes empirical formula. By multiplying the empirical formula with the number 2, we get molecular formula. So these are the steps to find out empirical formula and molecular formula.